Okay, so in section 3.2, we talk about completing the square. This is an algebraic technique that allows us to rewrite some of these quadratic functions in a different form. We do it in this class because after you complete the square, it's a little bit easier to see the vertex for the parabola that you would graph, sort of the shift and stretches involved. You actually see completing the square in other classes. You see it in calculus sometimes to help you integrate. You see it in differential equations also. So it's just a very useful algebraic technique that we want to understand. And again, it just takes a given quadratic function that's written in this form, ax squared plus bx plus c, and transforms it into a different form. Okay, one from which you can see the shifts, stretches, and things like that. All right, so we're going to go through the three steps that you need to do to complete the square. And again, keep in mind this is a little bit different than the way the book shows it. So try not to get the two methods mixed up. I think this one's a little bit easier to do. So again, keep in mind at every step, we're just rewriting the function. So nothing should happen to p of x. It should be the equivalent to this, but maybe rewritten a little bit. Okay, so again, the first thing we do is factor out the leading coefficient. So we need this to be 1x squared. So we factor out a 3. And it says x squared plus 1x. Now, keep in mind, completing the square means we're going to put a different constant term there. So we're not going to worry right now about the minus 6 because we pretty much understand that's going to be the wrong number to have there. We leave space for the correct number. So again, in what's inside the parentheses is where we complete the square. Okay, this should turn out to be, if we complete it correctly, a perfect square trinomial. Remember, a perfect square trinomial, then when you factor it, becomes some parentheses squared. So that's what we're trying to get to. Okay. Well, once the leading coefficient is a 1, so again, the 3 is just sitting outside. Once you have a 1x squared, whatever the middle coefficient is, in this case a 1, okay, you cut it in half. So most of the time we'll just leave it in fraction form, so 1 over 2, and then square it. Okay. That's the number that should be there to complete the square. Now we have to be careful because we just changed the problem, right? Changed the function. So we wrote a 1/4 in there, but again, keep in mind it's 3 times 1/4. So what I really have is 3x squared, that didn't change, 3x, that didn't change, plus 3/4. Well, if I want to keep that did change. So if I put a minus 3/4, that would balance it out. Now the function is equivalent to the way it started. Okay. So I have my perfect square trinomial, and it should always work. You could double check, but again, this right here is 1/2, is this guy right here. Okay. If you want to check, FOIL it out, you get x squared plus x plus 1/4. Okay. And then combine the two constant terms here. Remember, this in fourths would be 24/4. So this would be minus 27/4. Okay. So this is how you rewrite the given function in completing the square form. Keep in mind, from this you could see your vertex went left a half, down 27/4. And so again, in that form, this is the reason we like to complete the square is because this new form gives us the vertex immediately. Okay. All right, so let's just try this for a couple more. Again, the first step is to make sure you factor out that leading coefficient because you need it to be a 1. So in this case, I'm going to take out a negative 1. It leaves me with x squared minus 3x. Right, you've got to take out negative 1 from each. Don't worry about the plus 10. Leave room for the constant term that should be in there. Okay. So what should go here, and we always add it because it's a perfect square, so it has to be positive. You take your 3, right, you cut it in half, so just divide by 2, and then square it. So 9/4 should be here. Okay, now again, keep in mind, you wrote 9/4, but what you really put in here, right, you have a negative 1x squared, did not change. Positive 3x, did not change. But now you have a minus 9/4. So you need a plus 9/4 to balance that out. Okay? And now, assuming you've done everything correctly, this parentheses should be a perfect square. And in fact, it should be x, you take that sign, minus, and then the 3/2. Again, you can always FOIL it out to make sure that that's correct. Combine these. Remember, 10 is 40 over 4. So this would be 49/4. Okay. And so again, if you're asked to complete the square, you're just rewriting it, and that would be what it should look like. Okay. All right, so we'll run through a couple more, maybe a little bit more quickly. So we have p of x. You want to take out that negative 4, so it leaves you with x squared minus x. Again, be a little bit careful about your signs here. And that's it. There's no constant term to ignore. Okay, so nothing's changed yet. Again, our coefficient is a 1. Now again, keep in mind back here I missed, this is really minus 3, but it doesn't, in the end it doesn't matter because when you square it you'll get 9/4. But it's probably a little bit better to do that. So a negative 1, cut in half, and then square. Okay, so plus 1/4 is what needs to be here. That just changed the problem. It didn't change this, didn't change that. That's still negative 4x squared plus 4x. But I do have negative 4 times 1/4, which is a minus 1. So I better put a plus 1 to balance that out. So this becomes negative 4. This is a nice x minus 1/2 quantity squared parentheses. And then you have your plus 1. Okay. Alrighty, just a few more here. This one, it's kind of nice. It's already set to go. So there's nothing to factor out. I might still just put it in parentheses just to keep, again, the minus 15 out of it. Okay. Nothing's happened yet. I take my 2, I cut it in half, square it. Okay. So the plus 1 should go here. Now again, keep in mind, the coefficient out here is a 1. So you did add 1, so subtract 1 to balance things out. So p of x, this should now be a nice perfect square trinomial. In this case, x plus 1, quantity squared, minus this 16, minus 15, minus 1. This one, just kind of be aware, you have to take out a 4 because it has to be 1x squared. Now, 4 doesn't come out of 3 very easily, but again, this has to be 1x squared, so you have to take out a 4. Remember, when you factor out 4, it's dividing out the 4. So this really becomes just 3/4 x. Don't have to worry about the constant. And again, just double check. That's 4x squared. That's 3x minus 1. Nothing happened so far. Okay. So we take our middle coefficient here, which is 3/4, cut it in half, which again just throws a 2 in the denominator, so 3/8. Square it, you get 9/64. So that's the number that needs to go here. Now keep in mind, when you distribute 4x squared, nothing changed. 3x, nothing changed. But now you have this 4 times 9/64. The 4 cancels in the 64 16 times. So then you would have to subtract. So this really would be a 9/16. 4 into 64 is 16. So to balance it out, subtract the 9/16. Okay. And then you're all set. You have a 4. This is your perfect square trinomial. X plus 3/8 squared. Remember, that's this number here. And then combine, remember, this is 16/16, so this would be minus 25/16. Alright. Here we factor out our 2. X squared minus 4x. Don't worry about the 9. We have our negative 4. Cut it in half. Square it. And again, that's the number that goes there. Change the problem, right? 2x squared, nothing changed. Minus 8x, nothing changed. But this plus 8 is now there. Put a minus 8 to balance it out. And you should have created a perfect square trinomial. In this case, x minus 2 quantity squared. 9 minus 8 is 1. Okay, and again, this would be the form of your answer if you're asked to complete the square. And then let's make this last one. So again, we factor out the negative 3. X squared plus 6x. Don't worry about the minus 23. So we take our 6, cut it in half, square it. That's 9 is what should go here. Okay, so there's your negative 3x squared. Nothing changed. Negative 18x. Nothing changed. But this last one is a minus 27. So put a plus 27 to balance it out. Okay. And so finally you have negative 3 times the quantity x plus 3 squared. Negative 23 plus 27 is a positive 4.